So, in the series of learning C++ programming language, we are discussing operators in C++. In the last video, we have discussed arithmetic and relational operators, right? So, the next two types of operators we'll discuss in this video is logical operator and bitwise operator. With the help of program, I'll show you, right? Practical also we'll see. So, firstly, we'll see just logical operators. I hope you know what is an operator. In the previous video, we have discussed it's like just a symbol to tell the compiler which specific logical or mathematical operation is to be performed on the operands. I hope you know what is operand, what is operator now. It is clear to you guys. Now, logical operators. See, basically three logical operators we have: logical AND, logical OR, and logical NOT. It's logical AND, logical OR, logical NOT. The symbol is this for OR, this, and for NOT, this exclamatory symbol, right? So these type of operators basically, they are used to combine two or more conditions, right? And the operand for these operators are of type Boolean type, right? Let's see. If I have three numbers A, B, and C, and you want to find out maximum of three numbers, so I'll say if A greater than B and A greater than C, it means A is maximum. If I write like A greater than B and A greater than C, it means we can print A is maximum, right? So this AND, it's logical AND, so we can replace it with this operator AND. Means this logical AND operator is combining two conditions, right? And this is one operand for this, and this is another operand for this logical AND operator. So this operands should be of type Boolean, right? See, suppose A is equal to 10, B is equal to 5, and C is equal to 11, right? Now, is A greater than B? This is relational operator, greater than, right? A greater than B, 10 greater than 5, yes. True. It means it is true means 1. And A greater than C, no, false, that is 0, right? Now this operator will work on these operands. This is true, this is false, so it will give you false, that is 0. So the operand for these operators should be of Boolean type, right? Now logical AND operators will work how? See, if something like this, if both the operands are true, then only it will give true value, otherwise false value. The truth table, if I say, then for this logical AND operator is what? If both the operands are 0, 0, or you can say false, it will give 0. If one is true, one is false, then also false, this also false, and this will give true, right? So this is the, you can see the truth table for this logical AND. If both the operands are true, then only it will give true, right? Now, and for logical OR, the truth table is what? If both the operands are false, then only it will give false. If any of the one operand is true, it will give true. So something like this. For logical, this is for logical AND. For logical OR, 0, 0, 0, 1, 1, 1. If any one of the operand is true, it will give true. And logical NOT means if true, operand is true, it will give false. If false, it will give true. Means not 0 will be 1, not 1 will be 0 for this logical NOT. Now, how these operators work? Basically, they work on the method of short circuiting. I hope you know what is short circuit, or let me just discuss this thing also. So these both the operators, you can say, they perform short circuit evaluation. Now what is this short circuit evaluation? See, if the first operand, means if after evaluating the first operand, the result is known to you, right? Then it will not evaluate the second operand. This is what short circuit evaluation. they don't evaluate the second operand if the result is known after evaluating the first operand only. Now what does this line mean? See, here, see, A greater than B means 10 greater than 5, right? Yes, it is true. But after evaluating the first operand only, we cannot say what would be the result, because for logical and both should be 1. So you have to evaluate the second also. A greater than C? No, it is 0. Now you can say you have to, you have to evaluate both the operands in this case. Then only we can say what would be the result. If this is something like this, suppose B is 15. Now see, 10 greater than 15. Is 10 greater than 15? No, means false, that is a 0. In this case, it will not evaluate the second operand. Why so? Because after evaluating the first operand, first is false, and we know if any one of the operand is false in logical AND, it will give false ultimately. This is the truth table. If both are true, then only it will give 1. So it will not evaluate the second operand directly, the result would be false. This is what short circuit evaluation. I hope this point is clear to you guys. Same logical OR also work on this type of evaluation. If suppose I am not writing here this, I am writing here logical OR, and B is 5 only. Now 10 greater than 5, yes, it is true, so it would be 1. Now it will not evaluate the second one. Why so? Because the operator is logical OR, and in logical OR, if any one of the operand is true, ultimately the result would be true. So one operand is true, so we know the result would be 1. It doesn't depend that second operand is giving false. If this is false, then also it will give 1. If this is true, then also it will give 1. So it will not evaluate the second one. Only by evaluating the first operand we know the result. That's it. Right? So I hope these logical operators are clear to you guys. So in some situation, maybe you want to check 2, 3, 4 conditions, and we want all the conditions must be true. Then only we can do something. If you want to do something, then you will perform logical AND operator, right? Suppose if I say, if camera is there and board is there, whiteboard, and marker is there, then only I will shoot the video. Means all the 3 conditions should be true. Camera, I have board and marker, then only I will shoot. So I am putting AND in between these. If any one of these, this is false. If any one of it is not available, suppose board, whiteboard is not available, so I will not shoot the video, right? Second condition, if I take like if camera, if I say, if I have phone or maybe camera, I am fine with phone also. If I don't have camera, I can shoot with phone. So here I can take or like camera or phone, mobile phone. If I have camera but not phone, then also I can shoot. If I don't have camera but I have phone, that is also fine. I don't need both camera and phone. I need only one thing to shoot the video. So that is what logical OR type of thing. So this is how, I hope the basic idea is clear to you. Now you can relate it with your real life examples and you can visualize everything. See, try to relate each and every concept with your real life examples, right? In everyday example, then you will get it better and it will be in your memory for a longer period of time. So I hope this logical operators are clear to you. Now let's see bitwise operators. And see, one assignment for you is, if I write not 15, what value it will give? You have to tell me in comment section. Now bitwise operators, as the name suggests, bitwise means they work on bits. They perform operations bits by bits. They work on individual bits, right? Now let's see how they works. Here also we have bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift, right shift, right shift and left shift operators. This is what right shift and this is what left shift operator, right? Now bitwise AND, the symbol is this thing. So they work on bits. They perform operation bits by bits. Suppose I say I have two numbers, x is equal to 26 and y is equal to 9. and you have to perform x and y, bitwise AND. So first translate these into bits, zeros and ones in that form. So 26 would be this one and 9 would be 1 0 0 0. Sorry, this would be 1 0 0 0 0. In 8 bits I am representing, right? How you can translate, like if I say I write 1 2 4 8 16 32 64, like something like this, 128. 16 plus 8 plus 2, that would be 26. In these under these places we have 1 and 1 plus 8, 8 plus 1, that is 9, so we have this. So I hope you know how to convert decimal into binary. Now bits by bits you perform operation. Now bitwise AND, same, if both are 1 then only it will give 1, otherwise false. So now it will give what? 0 1 0, this is also 0 0 1 1, yes, that is 1 1 0 0 0 0 0. So bitwise AND, this is what in decimal we can say this is 8. So this is bitwise AND operator. If you perform bitwise OR, this is bitwise AND, this is bitwise OR, the result I am writing here. Bitwise OR means if any one is true, it will give true, otherwise false. 0 1, this is true, yes, 1 1 0 1 1 0 0 0. It will give what? See, 16 plus 8 plus 2 plus 3, it will give 27, right? Now bitwise XOR. Bitwise XOR means if both the bits are same, then it will give false. If both the bits are same, then it will give false, otherwise true, right? 0 and 1 not same, so it will give true. 1 0 true. 0 0 both are same, false false, so it will give false. True true both are same, then also it will give false. 1 0, one is true, one is false, yeah, both are different, so it will give 1. 0 0 both are same, 0 0 0. So the output, the result of this would be 16 plus 2 plus 1, 19. Now this is what negation, or you can say bitwise NOT operator. So if I say like something like this, negation of x, it will convert true to false and false to true, means 1 to 0, 0 to 1. So x is this one, y is this one. Negation of x, not x, would be 1 1 1 0 0 1 0 1, something like this, right? So it will give, in system if you will print like negation of x, then it will give 2's complement. The value would be 2's complement. The system will give 2's complement of x. And how the 2's complement would be converted? First of all, 1's complement, then add plus, add 1 to that. Or the formula is like if I say negation of x would be minus x plus 1. This would be 2's complement. So minus x is 26, 26 plus 1, that is minus 27. So in system, if you put bitwise NOT operator with x, it will give minus 27, right? It will give 2's complement. Fine. Now left shift and right shift. See, on x I am applying the shifting operation. So if I apply x left shift 1, we are going to left shift this by 1 bit. So x is this, means left shift 1, left shift 1. So this would be discarded, this 0 would be here, right? Then this 0 would be here, then we have 1, then 1, then 0, then 1, then 0, and 1 space 1 2 3 4 1 2 3 4 5 6 7, we have only 7. So the remaining bit would be filled with 0. So this would be left shifted by 1. If you want to left shift it by 2, this 2 left bit, these bits would be discarded. We will left shift these by 2, and here the 2 places would be filled with 0. I hope you got this. So if I write x left shift 2, then the result would be these 2 would be discarded. Now I write from here 0 1 1 0 1 0, and these 2 bits would be filled with 0. X left shift 3, these 3 bits would be discarded, and I'll write from here 1 1 0 1 0 0 0 0. These 3 places would be filled with 0, right? Right shift, if I say x right shift 1 means right shift that side, this is right side, this is left side. So right side, 1 bit from the right side would be discarded. I'll write from here 1 0 1 1 0 0 0, 3 zeros, and here the 1 place would be filled with 0. So this is what x right shift to 1. Same with 2 and 3, right? If x right shift 2 bits by 2 bits, then these 2 bits would be discarded, and we will start writing from here 0 1 1 0 0 0, then 2 0 filled with 2 0, right? So simply if you want to tally the answer, then how you can say, the formula is, if you shift like x left shift by n bits, then what would be the result? X into 2 raised to power n. So here x is 26, 26 left shift, n is 1. So the answer should be 26 into 2 raised to power 1, that is 52. X left shift 1, and the answer is this. You can try out the decimal of this is 52, like 1 2 4 8 16 32. So 32 plus 16 plus 4, that would be 52, right? Same for right shift, x right shift n, the result would be x divided by 2 raised to power n. So if I x right shift 1, this is the result. So result would be 26 divided by 2 raised to power 1, that is 13. So it is 13. 1 2 4 8. So 8 plus 4 plus 1, that is 13. So this is how you can tally the answer by this formula, right, for left shift and right shift. I hope you got, right? Now let me show you practical. Okay, so we have this program operators.cpp. Now we have this logical operator. This is the code, right? We have x and y, x is x5, y 10, and we are checking if x greater than 5 and y less than 15. Then see out, it will print x plus y. Else if x less than equal to 5, y greater than 15, it will give x minus y. Else suppose it will give not equal to x, right? Logical not x. Okay, let me just run this code and show you the answer, what you will get here. See, it is giving x minus y, that is minus 5. Why so? Because first condition is x greater than 5? No, because x is equal to 5. So only first condition is false, so it will not evaluate the second one, because if one is false, logical not will give false. So it will not enter into this if statement block. Now else if, next condition, x less than equal to 5? Yes, less than or equal to, yes, it is equal to 5. So this is true, right? Now it will not evaluate the second condition because it is logical or. So in this case, if only one operand is true, the result would be ultimately true. So yes, it would be true. Now it will enter into this else block and it will give x minus y, that is minus 5, right? So this is how these operators will work. They just choose to combine 2 or more conditions. Here you can put one more and some more condition, one more logical and some more condition, this kind of thing you can do, right? So now if I change the condition, else if condition, if I remove this equal to, now what output you will get? See, it will give now logical not x. So x is 5, it means true, so it will give false, because this condition is also not true. Now x less than equal to 5? No, that is 0, right, false. But it will check the second also, because 1 is 0, second is true, it will give true. So only by evaluating the first we cannot say what would be the result, right, in case if the first operand is 0. Now evaluate the second one, y greater than 15? No, this is also false. So ultimately this will give false logical OR operator and will not enter into this else if block and directly jump to the else block and it will print not x, right. Now let's see bitwise operators. Let me just comment the section out, and we have now bitwise operator. See what would be the result. X is 26 and y is 9. So let's run this code and see the result. X and y equal to 8, that we have discussed already. X over y would be 27, x XOR y would be 19, x left shift 1 would be 52, x right shift 1 would be 13, that I have shown you on the whiteboard, and not bitwise not x would be minus 27. I have told you why it is giving minus 27, because it is the system is giving 2's complement of the number, right. So now you can try out these operators with different operands, or maybe the operand directly constant you can write, rather than x and y you can write 1 or 0, or one operand can be x the variable, second operand can be any like 0 or 1 or any constant. You can try out these different type of variations, right. So just try these out, practice these operators on different type of operands, and the more you explore, the more and more about these operators you will get, right. So I guess that's it about logical and bitwise operator from my side. So in the next video we will see assignment operators and some miscellaneous operators in C++. So now it's in the next video. Till then, bye bye, take care.